The truck. It's the workhorse of globalization. The tires it rolls on are high-tech products. The tire tread is optimized to retain the vehicle's grip on wet surfaces. When the tread is worn down, it's time for a new tire. But sometimes old is better than new, and that goes for tires too. What's more, older is more eco-friendly to drive. That insight forms the basis of the innovation developed by Agnès Poulbeau at the tire manufacturer Michelin. The name of the technology is Regignon.
Regignon is an innovative form of tire tread that keeps on regenerating itself throughout the tire's lifespan. It reduces fuel consumption by 1 litre per 100 kilometres, and it causes fewer CO2 emissions as well, 26 grams per kilometre.
The Michelin research campus of Ladoux, north of Clermont-Ferrand. Agnès Poulbeau, a specialist in 3D design and simulation programs, is among the 3,500 or so employees here. Agnès Poulbeau loves puzzles and has a doctorate in applied mathematics. At Michelin, she has a job that combines both disciplines. As part of the team, her task is to design energy-efficient tire treads for trucks. During a conversation with a customer, she learned that even though they had equipped his trucks with fuel-saving tires, he hadn't noticed that he was using less fuel.
It really surprised me. But then I realized that he had replaced his old tires with new ones. The old worn tires resist less, so they use up less fuel.
Tire treads consist of different elements. Tire blocks ensure a safe grip on the road. The systems of tread grooves allow water to run off in the rain. This prevents aquaplaning and slipping. New tires have the deepest tread, so they have the best grip when it's wet. However, because of the deep grooves, the blocks get more deformed while driving. The tire gets hotter and wears down more quickly, and its rolling resistance increases. So a new tire is actually less efficient. It results in higher fuel consumption and more CO2 emissions.
So I ended up thinking the ideal tread would be half worn, but would also self-regenerate the whole time, for enough grip on one hand, plus better rolling resistance on the other.
In other words, the tire has to give optimum performance through substantially all of its life. But how would that be possible? Agnès Poulbeau got an idea that had never occurred to anyone. Instead of one deep tread, what about several shallower treads, one on top of another?
The three-dimensional challenge was to distribute the grooves at the right locations on the tread, as well as under the surface of the rubber. Quite a puzzle.
Where tires are concerned, reinventing the wheel isn't that easy. Agnès Poulbeau used a 3D design program to create several tread variants, and a simulation program to calculate how each tread would behave.
Developing tires is a complex physical challenge, and that's what makes it so interesting. You have to know how fluids behave so that you can estimate the grip and the water runoff. And you need to know about thermomechanics to evaluate the wear, which in turn affects the fuel consumption.
She received important insight from Jacques Barrault, the project manager, who passed away in July 2016.
I was the mathematician, the 3D design expert. I had ideas, I tried them out and showed them to him. And he was a leading truck tire expert who could avoid mistakes. It was this constant exchange that finally led the two of us to Regignon.
In addition to Agnès Poulbeau, the patent for Regignon also has Jacques Barrault's name. 4.5 years of development work resulted in all kinds of rubber architecture. In fact, up to 2 more treads are hidden inside the rubber of the new tires. Each tread layer is shallower than usual, yet still allows a maximum amount of water through, for good grip in the rain. Wear on the very top tread layer exposes the next one beneath it. As a result, the tire doesn't actually become worn at all, it regenerates itself. Shallower treads are more stable, they don't heat up as much, and they wear down slower. As a result, they last up to 20% longer, and they also have lower rolling resistance.
Road traffic produces 35% of the CO2 emissions in Europe. If all Michelin tyres were equipped with Regenyon technology, in 1 year you could save all the CO2 emissions produced by the city of Paris in a month.
Truck tyres with Regenyon technology have been on the road since 2013. It's a revolution, and a rare one where tyres are concerned.
I'm very proud that my invention has made it to the market and that thousands of tyres have been equipped with it. Also, we are helping to cut CO2 emissions. After all, road traffic is largely responsible for them. So it's a good feeling.